In this video, we will demonstrate how to combine two V6 real-time spectrum analyzers to increase bandwidth and stitch their spectra together using the Spectrum Stitcher block. We will build a mission around this block. First, add two receivers. In this example, both receivers are Spectran V6 eco units. Place them separately in the grid editor. Next, add two calibration blocks as described in a previous video. Connect the RF output of each calibration block to the RF1 input of each Spectran V6 eco. This ensures high accuracy for the RF path and overall performance. Click AutoFit in the ribbon bar to arrange the blocks. Now, convert the IQ streams from the receivers into spectra using IQ Power Spectrum blocks. Connect IQ Stream 1 from the first Spectran V6 eco to the IQ input of the first IQ Power Spectrum block. Connect IQ Stream 1 from the second Spectran V6 eco to the IQ input of the second IQ Power Spectrum block. Click AutoFit again. At this point, each antenna feeds a calibration block, then a V6 eco receiver, and then an IQ Power Spectrum converter. Next, connect the spectra outputs of the two IQ Power Spectrum blocks to the Spectrum Stitcher block. Connect the first IQ Power Spectrum to Spectra 1 on the Spectrum Stitcher, and the second to Spectra 2. Click AutoFit once more. To view the combined spectrum, add a spectrum block. Connect the stitched output of the Spectrum Stitcher to the spectra input of the spectrum block. Click AutoFit again. Now, configure the receivers. On the first Spectran V6 eco, set the center frequency to 2.420 GHz and the reference level to -20 dBm to avoid overdrive. On the second Spectran V6 eco, set the center frequency to 2.470 GHz and the reference level to -20 dBm. This configuration allows the two receiver bandwidths to overlap. Start both receivers by clicking Start on each Spectran V6 eco block. Both units are now active and can be identified by their unique serial numbers. Click AutoFit again, if needed, to tidy the layout. To display the stitched spectrum, click the green pencil icon on the Spectrum Stitcher block. This opens a combined spectrum view. If there is a gap between the two receiver bands, part of the available bandwidth is not being used. To close this gap and optimize coverage, adjust the center frequencies. Change the first receiver from 2.420 to 2.422 GHz. Change the second receiver from 2.470 to 2.472 GHz. The stitched spectrum now forms a continuous band from roughly 2.400 to 2.490 GHz and beyond. Return to the grid editor and confirm that the Spectrum Stitcher and Spectrum blocks are running and displaying live data. To enhance the visualization, add a waterfall block. Connect the stitched output of the Spectrum Stitcher to the spectra input of the waterfall block. Click AutoFit again. The full signal chain is now visible. Two antennas, two receivers, the Spectrum Stitcher, and both a spectrum display and a waterfall display showing the combined result. To open the waterfall view, click the green pencil icon on the waterfall block. You can now clearly see the combined real-time bandwidth of the two receivers through the Spectrum Stitcher block. For more information, check out our other videos on our YouTube page or visit eroniausa.com.